Okay, so now I'm just about ready to finish up chapter 6. And 6.5 talks about combinations. So we're choosing k objects out of n objects. Very important. The order is not important. Okay, what does that mean? It means ABC is equivalent to ACB, which is equivalent to CAB, etc., etc., etc. So in other words, we no longer have a first place, a second place, a third place. All we care about is I have these symbols showing up. And the formula for that is the following. It's the combination formula. So you're choosing k objects out of n objects. And actually we could think about this. If I look at ABC, let me write this, use a pen. ABC is equivalent to ACB, which is equivalent to, let's see, BAC, which is equivalent to BCA, which is equivalent to CAB, which is equivalent to CBA. I think I've got all of them, right? So, yeah. So notice that before, if we were talking about first place, second place, third place, we would have had 6 different things just with the symbols A, B, and C. Now what we're saying here is all these are equivalent. The order is not important, which means we're going to get a lot less possibilities because all the possible things with horse A, Alice, Bob, Cindy, any of these is equivalent. You could win the bet, which means we're going to have a lot less possibilities, which means we're dividing the numerator by another number. And it turns out that the result is the following. Piece of paper again. So it turns out that if you had this part right here, that's your permutation formula. But now we're also dividing by the number of things that you're choosing. So I'm choosing k objects out of n objects where order is not important, which means we don't want that double counting. That's why this guy shows up. Let's take some examples. Okay, so how many ways can we choose 4 objects out of 10 objects where order is not important? So A, B, C, D is the same as A, C, B, D, etc., etc., etc. So what we're going to do is we're going to calculate using the permutation formula. This is on your formula sheet. So a combination formula. So this part is just the permutation. Now this 4 factorial, the reason we're dividing is that's we're getting rid of double counting. Now, what I want you to do, please do not write this as 10 times 9 times 8, etc. Look at the 2 bottom numbers. If one of them is bigger, that's the one you're going to stop the top one at. Let me say that again. I have a 4 factorial and I have a 6 factorial. Choose the bigger one. So you're going to take the numerator and you're going to stop it at 7 and then 6 factorial. That way you'll be able to cancel a bunch of the 6 factorials. So what you do is you stop at 10. Oops, let me bring this up, sorry. So you're going to take the 10 and the 6. The 6 is the bigger. You're going to take 10, stop it at 7, and you're going to cancel the 6 factorials. Now you got to do something with the 4. So now we take the 4 factorial, which is what's left, and write it as 4 times 3 times 2 times 1. What I would suggest doing is start from here and try to go over and cancel, or actually you could start this way, cancel as many terms as possible. Notice the 8 and the 4 and the 2 cancel, so I'm left with 10, 9, 7, and then I still have a 3 left over. Cancel the 3's, one of the 3's, and you're left with 210. So here you have 2 factorial functions. Pick the bigger one, peel off the top, and stop it there. Then whatever's left over, like the 4, you're eventually going to have to what? Write that out. And you're trying to cancel as many things as possible. Okay, a student has 7 books on the desk. How many ways can the student select 3 books? Well, first question, is order important or not? How do we determine that? Well, is there any indication that the books are different? No, there's no distinction. I don't know if it's a math book, an economics book, accounting book. I don't know. I have no idea. And it appears that I'm just selecting 3 that I want to put in my backpack. That's it. So order is not important, which means we use the combination. So there's no reference to any importance of the book. Order is not important. You choosing what? 3 books out of 7. So we go 7 factorial. So this part right here is the permutation. Oops, sorry. Good idea to look at that. So we're doing the combination formula, which means we're choosing 3 books out of 7. Combination means order is not important. So this part right here would be the permutation problem. So you have 7 factorial over 7 minus 3 factorial. You get a 3 factorial, 4 factorial. This is the bigger one. Take your numerator and stop it there so you can cancel. So I take 7, 6, 5, peel off the 4 factorial. The 4 factorials cancel. Next, the 3 factorial is 3 times 2 times 1. Cancel the 6 with the 6. 7 times 5 is 35. When you've now got the number of ways you can choose the books out of, what was it, 7 books. Alright, now this is going to be a little trickier. Oops, I've got to stop this. Okay, so we have a club, and I have 10 members in this club. How many ways can a committee be formed with 4 members? How many ways can we form an administrative committee composed of a president, vice president, senator, a secretary, treasurer? So let's think about this for a moment. In part A, how many ways can a committee be formed with 4 members? Is there any significance to the members on the committee? No, it just says I need a committee. Do whatever. What about part B? How many ways can we form an administrative committee composed of a president, vice president, secretary, treasurer? So in this case, we are choosing 1, 2, 3, 4 objects, but don't these positions mean that they are all different? So in other words, this one is saying order is not important. There's no significance attached to each of the what? Members. This one says you're still choosing 4 people, but the positions are very, very important. So what is that telling me? This is a permutation problem. And this is a combination problem. No, order is not of any importance. Order is important. Think of it: first place, second place, third place, fourth place. So my first question that I have to ask is order important or not important? The original, the just 4 members, it's not important. You're doing combination. For the administrative one, though, the order is important. How many people do I have? 10 available. How many am I choosing? 4 out of the 10. So the order is not important. We have combination 10 choose 4. Order is important. 10 choose 4. P. And if you go through the arithmetic, you get 210 and 50, 40. So it's very important to ask yourself right up front, is the order important or is it not important? If it is important, we use permutation. If it's not important, we use combination. Okay, cafeteria offers a selection of 4 meats, 6 veggies, and 5 desserts. How many ways can you select 2 meats, 3 veggies, and 2 desserts? Question number 1. Is order important or is it not? Sorry about that. Let me just pause this for a second. Okay, so first question. Is there any kind of distinction about what types of meat? Is it chicken? Is it pork? What? No, there's no distinction. Do we have any kind of distinction between what kind of veggies there are? No. Or desserts. All we care about is you're needing to select 2 meats, 3 veggies, and what? 2 desserts. I want you to notice we're saying 2 meats and 3 veggies and 2 desserts. That's a multiplication principle. Okay, so in other words, if we go back to our multiplication principle, order is not important. So I have available to me 4 meats and I got to select what? 2. And I've got 6 veggies and I'm supposed to pick out what? 3 of them. I've got 5 desserts and you pick out 2 desserts. So the order is not important, which means we're going to be using the what? The combination formula. Okay? So we're choosing so many objects out of so many that are available. Now be careful here because we have different things that we're selecting. We're choosing from meats, veggies, and desserts. So if we want to choose 2 meats, there's 4 available. So we're going to have to choose 2 out of the 4. And I want to choose veggies, 3 out of the 6. And I want to choose 2 desserts out of the 5. The order is not important. So that gets us to the following. So when we go to do the veggies, we're choosing 6 out of 3. We're using combinations. We have 5 desserts. We're choosing 2 out of them. Let me just check one thing here. Right, so remember we have 4 meats, we're choosing 2, 6 veggies, 3 of them, and 5 desserts, and we're choosing 2 out of those. So the multiplication principle says you're supposed to be doing what? Meat and veggies and desserts. Think of your ice cream problem. You had flavor, cones, toppings. You wanted all 3 of those things. So you have 4 available, you're choosing 2. Order is not important. You have 6, order is not important. You have 5 desserts, you're choosing 2. So in other words, you multiply these numbers. So the multiplication principle says when you calculate those, you just multiply. So you calculate the C of, etc., 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 and then you multiply. Now one more important concept is the addition principle. When we say you have choices, choice A, or choice B, or choice C, or, in this situation, you just add up the choices. When you say this, and this, and this, you do multiplication. Now just to be sure, if we said this, and this, or this, it would be multiplication and addition. So this is where confusion is sometimes going to come in, is when you have mixtures of probability and of permutations and combinations. Okay, I tell you, a parent-teacher association program committee decides to ask 4 students to participate in the program. They want students from either Mr. Dudley's class of 14 students, or from Mrs. Jane's class of 17 students, or from Mr. Bowden's class of 15. How many ways can this be done? All right, I want us to stop and think about this. We have students from this class, we've got students from this class, or students from this class. What does or mean? Addition. This can happen, or this can happen, or this can happen. So let's take a look at this. They want students, the committee decides to ask 4 students to participate in blah, blah, blah. They want students from either this one, or this one. So what does that mean? Well, I could choose 4 students out of this class, or I could choose 4 students out of this class, or I could choose 4 students out of this class. Is order important here? No, all I care about is just 4 students. That's it. So what we've got here is the first class has 14 students available. Sorry, it's not at the screen. And we're picking 4. So I have 14 available. I'm choosing 4. The next class, Jane's class, I have 17 students. I'm picking out 4. Last class, Bowden's, I've got 15 students. I choose 4. So on a quiz or a test, I will just ask you to do this. So order's not important, order's not important, order's not important. And since it's this, or this, or this, I use the addition principle. Okay. And I'm going to have to stop this one because the next one is going to be a little bit, so this will be on the next.